and welcome. My name is Janani Subbiah, and today we're going to be talking about Android, iOS, and web, best friends forever, the BFF pattern. Before we get started, a little bit about me. My name is Janani, and I currently work as a product architect for a company called Detroit Labs, based in Michigan, USA. Most of my experience in the software industry comes from building a few Android applications and working on backend systems. I love to read, travel, and balcony garden. Given how 2020 went, I did a lot of reading, no traveling, and I've been experimenting in my balcony garden where I try to grow fruits, vegetables, and herbs from store-bought produce without having to buy the seeds from nurseries or any other place. This started out as an experiment a couple of years ago, and it's continuing into 2021, and I cannot wait for the current growing season because I have a lot of seeds to experiment with. So getting back to the BFF, in today's talk, we will start off with what a BFF is, what it stands for from an abbreviation point of view, and what it means from an architecture point of view. We'll go over some of the advantages of using the BFF pattern, and then we'll also go over some of the disadvantages of using the BFF pattern, followed by talking through some tips and tricks that will take a step closer to mitigating some of those disadvantages. And finally, we will also talk about when would be a good time to consider if the BFF pattern is good for your application. And we'll conclude with all the wonderful things that we'll be talking about. So on that note, what is a BFF? My title was not just a play with words. A BFF is partially this, it's best friends forever. But as far as pure abbreviations point of view go technically, a BFF could stand for one of two things. It could be backends for frontends, meaning multiple backend systems for frontends, or it could be a single backend for multiple frontends. And that's as far as the abbreviation goes. But from an architecture point of view, a BFF can be thought of as a service that sits in between a single UI or multiple UIs and various other IT systems that the UIs would otherwise have to interact with for all UI related things. An important thing that usually comes up while talking about a BFF is, well, is this a middleware? Or if it is not, how is it different from a middleware? A BFF can be thought of as a middleware that is specifically tailored for UI experience. And that is how a BFF and a middleware are related. So let's first look at backends for frontends. And as the name suggests, we're going to have multiple backends here. And as an example here, I've picked, say, an iPhone, an Android phone, and the web. So when we say backends for frontends, we're going to have two different types of BFFs. We could have a mobile BFF that basically is responsible for serving requests from the mobile applications. And we could have a web BFF that takes care of serving all requests originating in the web application. And under the hood, both these BFFs could be talking to a similar set of services. They could be backend services, they could be third-party APIs or other middlewares to make sure that requests originating on the UI are successfully responded to. And in this particular example, we've broken out the BFF based on the device, or rather the real estate on the UI, because web apps have more space for display. Maybe we want more information displayed to the user as compared to a user who's probably using the mobile version of the application. There are several other criteria that could be used to break up BFFs. It could be based off of user experience. Maybe depending on what type of user is logged in, we want a separate set of responses. This is just an example of where we break it up based on screen size or just space available on the UI. While talking about backends for frontends, I think it would be unfair not to talk about this article from Netflix. It's titled Netflix Embracing the Differences Inside the Netflix API Redesign. And this is similar to backends for frontends, where there are three layers of code. The first layer, or rather the bottommost layer, is the server code, which is a Java API responsible for collecting content from other servers or for collecting information that may be needed by applications running on different devices. And on top of this layer sits what's called the client adapter code. And this is the code that makes sure that whatever comes back from the Java API can be translated into API responses, or rather just responses in general, that can be more easily used by the client that it targets. And the client code is basically code on the client device. It could be the code that's running in your JavaScript app. If you have a web application that's written in JavaScript, it could be the code running on your Android phone if you're supporting an Android device. So the flow of requests would go as follows. If, say, we have an iOS device and there's client code running on that device is going to make a call to the iOS specific client adapter code that under the hood is going to use the Java API to collect all responses and make sure that those responses are processed and sent back to the iOS client code in such a way that it's more easily usable by the device. And similarly, if we had other applications like an Android code or an Android device with some client code running on it, that code would make a call to an Android specific client adapter, which again under the hood would use the Java API. And if, again, this topic is of interest to you, I would highly recommend giving this article a read. So that is backends for frontends. Next, the other version of the BFF is backend for frontends, which, as this diagram depicts, is a single BFF that sits in between multiple UIs. In our case, we have, say, an iPhone, an Android phone, and the web. So this BFF sits in between all of those UIs and all the backend systems that the BFF will be talking to in order to process requests from the UIs. This is another version of the BFF. And if you're wondering which one to pick, my recommendation is maybe start off with one and split them out into more than one BFFs if the need arises. So on that note, let's next talk about all the advantages of using and implementing the BFF pattern. The first one, I guess is mostly a very obvious advantage of using the BFF is the BFF, because of where it sits and because of why it is brought in the first place, acts as an orchestrator. And what I mean by this is, say the BFF doesn't exist, for example. Now the UIs are going to have to make calls to all these services. And if we add a layer of, say, complicated data processing or data retrieval on top of that, it's going to be hard for the UIs to, make sure that all of those calls go out correctly, or maybe they also need to go out in a certain order. And keeping track of all those things can be done, but if all of this common logic can be moved into a shared service called the BFF, then the BFF can be responsible for making sure the right services are called and the right services are also called in the right order, and can basically make sure that any incoming request from the UI under the hood is orchestrated into a series of requests that will result in a successful response to the UI, while also making sure that the UI is receiving responses that it can easily use. The next one is UI-specific APIs. Again, because of where the BFF sits, the BFF is going to be that single point that responds to the UIs. So say there are things that the UI needs for UI-specific things, the BFF can be responsible for making sure that it is not only orchestrating all the calls to all the backend systems, but also making sure that the responses passed back to the UIs are more tailored for UI experience. So if the UI were to need, say, if the UI doesn't need information that might be otherwise passed back from downstream services, the BFF can take care of, not passing that back to the UI so that the UI is not receiving a lot of noise or is not receiving responses or parts of responses that doesn't really pertain to them. And similarly, the flip side is if there is additional information that needs to be added, the BFF can also take care of that. And as mentioned earlier, if we have, say, complicated data aggregation or even just data that needs to come from multiple sources, the BFF can make sure that all of the data is collected and is filtered down into API responses that are more easily usable by the UI and that pertain to what the UI exactly needs. The next one's caching. Again, because of the location of the BFF can act as a wonderful caching layer. I also want to add that this definitely depends on and is driven by cache control headers. But say everything works well, and we have cache control headers in place from all the services in play. The BFF can make sure that it can cache responses from, say, downstream services, and this in turn would lead to less load on downstream services. Again, this becomes very helpful if you have multiple services that you're talking to, because this also makes sure that response times to the UI are improved. So say the web app makes a certain request, and we have a single BFF for all the UIs. So let's say the web app is the first one to make a request to the BFF. The BFF is going to go collect all the information required to respond back to that request. It's going to cache them. And next, irrespective of which device comes in with the same request, so as far as cache control headers are implemented and that cache response is still valid, the BFF doesn't have to go all the way out to downstream services again to fetch those responses. Instead, it can just use things from its cache. Again, very helpful when you have multiple services you need to talk to, or when there is complicated processing logic involved. And finally, if downstream services are down for whatever reason, and say the cached values are still valid, the BFF can continue to successfully respond to requests from the UIs, because now it has that cache layer that acts as a buffer until they run out, to make sure that responses can be sent back successfully. The next one's lesser code duplication. So imagine a scenario where there isn't a BFF. So now all of the individual UIs are going to have to make requests to downstream services or third-party APIs, or there are things that all of them are going to have to do in their individual, stacks over and over again. And when a BFF comes into play, all of that common logic is pulled out of the UIs and put in the BFF in a shared location. And this ensures that, one, UIs can focus on UI-specific things. And number two, just very similar to how we would code a single code base, this is making sure that all common code and logic is encompassed in a service that can serve multiple software entities. The next one is it becomes easier to take updates. And by updates here, I am referring to, say, downstream services maybe going through their iterations or changing APIs or any other changes that the UIs may have to deal with. Now the BFF can take those changes. And the biggest advantage of this is this will ensure that the BFF handles those changes while also ensuring that APIs to the UI are either kept passive or need to be changed only in one place, and everything works as expected in an ideal world. The next one's consistency, and this is probably by far my most favorite one. Say somebody comes to you with, hey, this particular thing is broken on the web app, and say you have a BFF implemented. The first question you could ask them is, did you get a chance to check this on the iOS and the Android versions, assuming you support all three of them? And if the answer is yes, chances are something is broken in the BFF. There are definitely chances that something is broken on multiple platforms here, but I guess the chances of something being broken on the BFF is probably slightly higher. And with consistency, if something is wrong, it's wrong in all the places. This is not great, but it's only a single place that needs to be fixed more often than not, and everything is fixed across all the UIs. And it's also consistency across UIs in terms of what response they expect. So it becomes easier to test. It also ensures, consistent and good user experience, because it's the same response that all the UIs are dealing with for their API calls. So similar to UI-specific APIs, having a BFF also allows teams to implement UI-specific features much faster and more efficiently. And more importantly, backend systems do not have to worry about UI-specific features. And when I say UI-specific features, an example could be push notifications. So the BFF can take care of implementing APIs that could be useful for push notifications. The one caveat here is this might open up the BFF to some kind of storage where it might need to store information regarding these UI-specific features, but the biggest advantage is because it is so tailored for UI experience, and because the BFF exists there for the UIs, it might not be a bad place to implement UI-specific features. And the next one is getting ahead. And what I mean by this is UIs don't have to wait for backend systems to be completely fleshed out and ready before they can start development. This is huge, and at a very high level, this can be broken down into 4 steps. The first step is for the BFF team and the UI team, or UI teams in some cases, to get together and talk about the contract between the BFF and the UIs. This could be driven by design, this could be driven by other requirements, but basically for both of these teams to communicate what is needed and how it can be fulfilled. And the next step is for the BFF team to take all this information to backend services that they know they'll be talking to, and making sure that there is some place in one of the services where all the information that the BFF has promised the UI can come from. So making sure that the contract between the BFF and the UI is implementable. And step 3 is to actually implement the abstraction, which in our case is the BFF itself. And for all future iterations of changes that backend services might do to their services, or third-party APIs might make implementation changes, the BFF can take care of handling all those things, and the UIs wouldn't even have to know. And this way, the UIs can get ahead in their development lifecycle versus having to wait for everything to be ready before they can get started, because the BFF will take care of making sure that those consistent APIs to the UIs are promised and will stay available. So we've reached the end of all the good things about using the BFF. Next, we'll be talking about some of the disadvantages with the BFF pattern. The first one is the BFF pattern is more lightweight when there is no database storage attached to it. Technically, there is nothing that stops us from adding some database storage, but it's just easier and simpler to deploy and scale a single service versus a service attached to some kind of data store or storage in general. So let's consider an example to understand how having no database storage could be a tiny disadvantage. So say the BFF is talking to a service to fulfill requests from an iOS device, right? So what happens here is, say the service passes back information to the BFF that is not required by the BFF, or the BFF is not going to care what that looks like. And say the UI is also not going to look at what that information looks like. So with that scenario in mind, if the BFF did not have any storage available, one of the ways to get around to having that information passed back to the service, another thing, say the service needs that information back for all its future processings. One of the ways of doing that would be to have that block of information passed to the BFF and passed all the way down to the UI, and have the UI pass that back to the BFF when it makes requests, and have that information passed back to the service. The problem here is the UI and the BFF are, especially the UI in this case, because the BFF is there for this very purpose, is receiving information that it doesn't need, So what happens here is, just because the service needs additional information, it needs to be passed all the way to the UI and back. But if we were to attach some kind of database or data store availability to the BFF, what the BFF can do is maybe store that information in the database and not pass that down to the UI, so basically cutting off what is not needed by the UIs. And when the UIs respond or make a request to the BFF can then make a lookup and retrieve that block of information and pass that to the service. So only the service that needs it gets it. So this is if database storage is available. But a tiny advantage of not having database storage is that that service can choose to change that information as they see fit. Because the BFF and the UIs are not going to care about what that looks like. And again, this depends on implementation. And if it's also implemented that way, it doesn't matter how the block of information changes. The service can be sure that it will receive that information just as it was passed. The next one, which in my opinion is probably a very tiny disadvantage, is no matter what, the BFF is an additional service, additional component. So that means +1 to deployment, +1 to maintenance and updating. I say a tiny disadvantage because what the BFF brings in is huge, and this is probably a small price to pay for that. The next one, and probably one of the more important ones, are hidden failures. So let's consider this example to understand what I mean. So say the Android device makes a post request to the BFF, and on receiving that post request, the BFF is going to go ahead and first make a GET request to service A, followed by a post request to service B, and finally followed by a patch request to service C. And let's also consider a scenario where the patch to service C fails, which in turn will result in the post from the UI failing. So the UI is going to see a failure when the patch fails. Here, unless other things that we'll be discussing in the next section are in place, it becomes really hard to be able to pinpoint exactly where failures happened, because one, the UI really doesn't know what the BFF does under the hood, and number two, any of these calls to services A, B, and C could have failed. Without really having other things in place, it's very hard to pinpoint where failures have occurred. Similar to that example, or rather using that example, the other thing that's hard is to maintain a one-on-one mapping between HTTP verbs. So I'm going to consider the same example here. Here we have a post UI that is exposed to the UI. A post request that is exposed to the UI that under the hood makes a GET post and a patch request. That post from the UI could have very well been a GET, a post, or a patch. It doesn't have to be a post. And it becomes hard to figure out what that UI to BFF API HTTP verb needs to look like, especially when you have different verbs going out from the BFF as a result of that incoming request. And here, if all three of them were GETs, say the calls to A, B, and C were GETs, then that would probably be an easy scenario where we pick a GET. But if they are not, then it becomes hard to decide. One suggestion here would be to look at what the UI looks to do with that API. So if the biggest thing or biggest value to the UI is creating a resource, or if the biggest value to the UI is just fetching some information, maybe that can be used to drive that HTTP verb on the API between the UI and the BFF. The next one is web versus mobile. And this is probably more specific to scenarios where we have a single BFF that processes requests from mobile as well as web applications. Web applications have specific needs that don't really pertain to mobile apps. A couple of examples here include cross-origin resource sharing, also known as CORS, and we also have cross-site request forgery, also known as CSRF. And because we have a single BFF for multiple UIs, that BFF is also going to have to make sure CORS and CSRF are in place for web apps. So as far as the mobile apps are concerned, now there is code in the BFF that doesn't really pertain to mobile applications or experience on mobile applications. Again, one solution to this would be to have separate BFFs, one for the web and one for the mobile apps. But going back to my prior suggestion, I think it's a good idea to start off with a single BFF and see how things go, then maybe breaking them out into multiple BFFs versus having multiple BFFs in the first iteration itself, and ending up with probably a lot of duplicated code. So it's a good idea to start with one and maybe split out if need be. Similar to the BFF itself, the BFF team also acts as an abstraction, and this works great when everything works really well. But when hell breaks loose, depending on the size of your BFF team and depending on their availability, this could become a tiny problem, because it's only the BFF team that knows about exactly how data from multiple sources is combined and maybe other things are added before being passed on to the UI. Just the UI teams or just the backend services teams that the BFF talks to don't really have that information or haven't really written that code. So again, depending on a few other factors, this is something to consider. Your BFF team could be a wonderful layer of abstraction when everything works, but when hell breaks loose, it becomes absolutely necessary for at least one person from the team to be available, through debugging sessions and other things. So on that note, I have reached the end of some of the disadvantages of using a BFF. Next, we'll talk through some tips, tricks, and tools to use that will help with taking us a step closer to mitigating some of these disadvantages. The first one I'm going to be talking about is Charles, which is nothing but a proxying tool. So basically, Charles can be put in between any two, say, software entities that make calls to each other. And all it does is it's going to proxy requests from, say, a certain software entity. And Charles is very useful in two different scenarios as far as the BFF pattern goes. The first one is to proxy all requests that originate in the BFF and go out to all the services, middlewares, and third-party APIs. Charles can also be used to proxy services that originate in the UI and make their way to the BFF. And Charles is very helpful in helping UIs get ahead, because if Charles is put as a proxying tool in between the UIs and the BFF, the UIs can continue to use Charles with a couple of features I'll be discussing in a second, and that can mimic responses from the BFF. Two options with Charles in particular are rewrite rules and map local rules, and these are just things that help with mimicking the BFF's behavior without actually having the BFF respond with these things. So map local rules are especially very useful when you want to store JSON responses, assuming your project uses JSON as such, and you can have those responses passed back from Charles. And Charles is also very useful for testing error scenarios. Maybe your BFF is actually up and working pretty awesome, but you want to test a scenario where a 500 is passed back from the BFF, or you want to test how the UI responds when the BFF is down. Charles can be used for mimicking all those error scenarios and testing them out, making sure that we can test scenarios that are probably not immediately available. The next one's documentation. Documentation is big and probably can be a talk in its own right. And documentation is important for, I guess, every project, not just software projects, but it becomes more important for a project where there's a huge layer of abstraction in the form of the BFF. There are two different types of, or rather, two different kinds of documentation. The first one is using a tool like Swagger to document all the APIs. This includes like all the APIs that are being interacted with in the system. So this includes things like what the APIs look like, what they do, what the request and the response bodies look like, what is expected to be presented on the API, what is required and what fields are optional. It also includes things like error messages, what comes back, what are the different error scenarios, all those wonderful things in Swagger in the form of API specs. The audience for this is mostly developers, but it could totally be used by other folks on the team as well. The other type of documentation that I think really helps is having a GitHub repository with other API and non-API related things. The first thing that can be housed in this GitHub repository are screenshots. Say the UI changes based on the response from the BFF, then we can capture all those things in screenshots to, document that behavior. Sample responses can also be stored in this GitHub repository. These could be entire sample responses or just bits and pieces of responses that actually drive certain sections of the UI. And there can also be links to Swagger APIs if somebody wants to check them out. And Charles rewrite and map local rules could also be housed here for all developers, so that they can use this for testing. Similar to documentation, logging is also extremely important, becomes more important when it comes to the BFF. Logging all requests and responses is important because that will help us pinpoint hidden failures, or basically just answer the question of where did this happen and what happened. One important thing to note here is make sure that your requests and responses are not logging any sensitive information, which could be security related information or just personally identifiable information. Make sure that none of those things are logged. So it's important to remove them from the logs or mask them depending on the industry you're working in, but just something to keep in mind. Another option for logging is to use a tool like Splunk, which lets you aggregate logs and visualize it better. So you can search by certain exception types. You can search over a certain time range. So that's another option for logging. The next one's error messages. Error messages need to be meaningful to the developers, to end users, and at the bare minimum, what they need to do is tell who was using the app, what happened, and how it affects them, and where it happened. Again, one of those things that helps with pinpointing hidden failures or errors, especially in a system where there are multiple interactions for, say, a single request. And during development, this can be very helpful because it'll be easy for teams to know exactly where the problem is and where the fix needs to happen. So error messaging, again, very, very helpful and important. And finally, Integration testing sessions. So these are sessions that happen periodically. It could be once a sprint, it could be however often you want them to happen. And they also help with, making sure that what the teams worked on so far works as expected. So these sessions typically include at least one person from every team. This could be, one person from each of the UI platforms, one person from the BFF team, and one person from all the service teams that the BFF uses. And everybody gets into a meeting and they run through demo scenarios. And this helps with identifying issues and quickly, identifying where the issue is. So as they're running through scenarios, say something comes up, because everybody involved is in the room, it's easy to, just look at what happened, and it's easy to talk to the team that actually worked on probably the component where the error is happening, so we know exactly where that fix needs to happen. Again, helps with faster feedback, and this is extremely helpful when you have a lot of abstraction going in your project. So on that note, I have reached the end of all the tips and tricks for mitigating some of the disadvantages, or at least taking us a step closer towards mitigating some of the disadvantages. Now for the big question, right? If you're wondering, all of this sounds great, but is there a hard and fast rule to figure out when a BFF is a good investment? I guess there isn't. There are some questions that need to be answered before you figure out if a BFF is a good choice for your project, but I'd say there are a couple of scenarios or a couple of questions to start asking yourself. A BFF is probably a good investment when you have multiple UIs that need to, talk to different services or have just complicated data retrieval and aggregation logic. A BFF is probably a good investment in that place because it can collect all that, all the things that need to happen into a common place, and it can let UIs focus on UI-specific things. But even if you didn't have multiple UIs, but you have very complicated, say, data aggregation logic, or the UI just needs to talk to multiple services to get the information it needs, a BFF might still continue to be a good investment, again, because it leads to separation of concerns. The BFF can actually take care of all the orchestration, data retrieval, and processing, while the BFF can actually take care of all the wonderful things like making sure the user has a good experience, making sure the right data is displayed, making sure the UI responds well to whatever end users might do on the app. So these two questions, in my opinion, would probably be some of the first things to consider when you're considering a BFF in your application. So in conclusion, I just quickly wanted to summarize all the things we looked at today. We started off with what a BFF is, what it means, what it stands for, and where does it sit as far as the architecture of an application goes. Next, we talked about some of the advantages of using a BFF. We also talked about some of the disadvantages of using a BFF. We went through some tips and tricks that can help with mitigating or taking us a step closer towards mitigating some of the disadvantages. And finally, for the big question, what are the things we need to start asking ourselves before we can decide if a BFF is a good fit for our application? So on that note, I have almost reached the end of my talk, and I would like to leave you all with this. My BFF is not for everybody, but mostly everybody needs one, especially if they're building a multi-platform app. And I also want to add that having a BFF for a single UI, is not necessarily a bad thing in a lot of cases, because I guess one of the arguments that could be made is, hey, because it's a single UI, maybe we should just have this UI do everything without having to invest in a separate service. But investing in that separate service early on might help with, taking your other platform applications to market faster, because you already have done a piece of the work by investing in the BFF. Again, totally depends on what your plans for the application look like. So on that note, I've actually reached the end of my talk, and here are a couple of articles that I think you'll find very helpful if this talk was interesting and if this concept was interesting. Thanks a lot for being here. Thanks a lot for your attention, and have a wonderful day.